podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macy, and today I'm interviewing Sebastián Ramirez about FastAPI, a framework for building production-ready APIs in Python 3. So, Sebastián, can you start by introducing yourself?
Hello, Tobias. Thank you very much for having me here. So I'm Sebastián Ramirez. I'm a software developer from Colombia. That's why the accent. I'm currently living in Berlin, in Germany. I work for Explosion, which the creators of Spacey, the NLP package, and Prodigy, the machine learning annotation tool. So yeah, that's me.
And do you remember how you first got introduced to Python?
Yeah, well, actually, I started doing like web development and just like plain JavaScript stuff, even before there was like Node.js, or at least it was not like mainstreams. And I was doing like a bunch of online courses, everything in JavaScript because that's all I knew. And then at some point, one of these courses required doing Python. And I was like, yeah, well, let's just try it. And I just started the course without knowing Python and just trying to learn it on the while I was taking it. And I ended up liking it a lot. And from then on, I ended up building everything mainly in Python.
And so now you've been working in Python for a while. You're working for a company that is making good use of it in the machine learning space, and you've also ended up creating this web framework. So can you start by describing a bit about what the FastAPI project is and some of the frustrations that you ran into with other frameworks that motivated you to create an entirely new one?
Yeah, FastAPI is a web API framework for building modern applications. So it has like high performance, it's easy to learn, it's very fast to code, like writing the code using FastAPI is very fast and easy. And it's ready for production, like it's being used in several production applications, in several places, and it's all based on standard Python type hints, type annotations. So by using these modern, recent type annotations, you get auto-completion everywhere in like all of the editors, and also type checks. So you get type checks for free in your editor that tell you like, hey, you cannot like combine this string with an integer or stuff like that you wouldn't get if you didn't like have these type annotations. That's all by using plain type annotations in Python. But then FastAPI uses those standard type hints to generate automatic API documentations and to do validation for the data and serialization, like data conversion and all this stuff. And this is like all mainly for building JSON web APIs. So that's like more or less like what FastAPI is. Now, what are the frustrations or things that made me end up building FastAPI? I prefer to think of it as inspiration from other frameworks and also like other tools. More than frustration, because there have been like a lot of ideas that have been taken from different places that ended up like in FastAPI. So, for example, you have like a Django REST framework that was one of the first things that I saw that could provide like automatic API documentation that was like amazing. And you have like the simplicity of Flask, that you can build like a very simple application that doesn't even require a database system for building an API for cases that don't require a database. And there's like a bunch of frameworks and ideas that come from other places. For example, at some point they created this standard Swagger that then became OpenAPI. These tools didn't even exist before, when there were these standards didn't exist when they created the previous frameworks. So then there were a lot of additional tools to integrate these standards with the frameworks that already existed, and they did a lot of work, and they did a great job with the tools, and they capabilities that were available at the time. What FastAPI did was try to take these ideas and like combine them with, for example, with the new ideas of new frameworks like Async that provided a very high performance web framework for Python that was like on par with the Node.js and stuff like that. And then like combine this performance with the standards, with the tooling and all the ideas in a new framework that was all based on standard Python type annotations. And this is probably the main thing that FastAPI did on top, which is like having it all based on standard Python type annotations. And it's all powered underneath by Starlet, which is like the one of the at least one of the fastest Python frameworks. But Starlet is mainly like a bare bones framework or toolkit for building tools on top of it. And then FastAPI uses that and on top adds Pydantic. That is the thing that does all the data validation and parsing and all this stuff. So like there have been like a lot of tools that have inspired the things that are done in FastAPI. And then like the additional stuff that I was trying to solve that was not yet solved that ended up like giving birth to FastAPI was to make it all based on the open standards like OpenAPI and JSON schema and OAuth 2, which is like integrated into OpenAPI. And with that, to have like automatic documentation using, for example, Swagger UI or Redux, which are tools that are based on these same standards. So like by being based on standards, it's easier to integrate everything together and to build like more powerful tools that are like supported on each other. So yeah, that's like the main things that ended up like making me build FastAPI to provide these new tools and these new ideas on top of the ideas from many previous frameworks.
And what are some of the types of projects that you were working on that motivated you to put in the effort to actually build out this new framework using all these capabilities from the tools that came before, and some of the main use cases that you had in mind as you were designing the initial implementation of the framework?
So like at first I actually had like a bunch of combinations of tools and plugins with other frameworks like with Flask and stuff to like try to achieve more or less what I was trying to do. And I was working for like several startups before I joined Explosion. And like I got the chance to build many different projects like from scratch. So I was able to improve every time what were the tools that I was using for each one of these projects. Most of them had to deal with like data handling and machine learning and like data processing and stuff like that, which is like kind of a common case currently, but also all of them also had like a lot of simple CRUD and like create, read, update, delete data management, which is like very generic and applies to many applications or most of the applications. So it was actually like building all of these new projects one after the other that I ended up like building this combination of tools and plugins, and that combining those ideas with the new tools that I was learning to use and to apply, that I ended up thinking that maybe it was a good idea to combine those new tools with all these previous techniques that I was already saying.
And another interesting element of the current trend of web frameworks and web development is this focus on API first frameworks and eschewing some of the end-to-end capabilities that are built into some of the earlier generations, such as Django, where it incorporates the view layer and the HTML generation. And I'm wondering what you find as being the benefits of building the API first or API only framework and some of the challenges that are imposed by having that incorporation of the view layer in the framework itself.
Yeah, so like many modern applications end up having like a separated backend and a front end. And in many cases, it's even like front-end team independent of the backend team. And because like many modern applications end up using building the front end with JavaScript library like React or Vue.js or Angular or things like that. And then they end up communicating with the backend through an API. That has the benefit of like separating like concerns between the front end and the API, and that also like has the possibility to like build an API that is not necessarily only for a front end, but also a system that service that can be used by another backend systems, by another backend services, by mobile applications. So I guess like that's probably one of the main benefits, apart from like all the improved user experience from these modern UI frameworks. But yeah, like that's probably like what I think has been driving this tendency of separating the API from the front end every time more. Nevertheless, like if you want to use like a let's say a common approach or an older approach of having the front end built with templates in the backend, you can still do that with FastAPI using Jinja templates, and you can use like SQL Alchemy models, and you can like end up having like a very let's say early age standard framework. It probably won't show much of the benefits of FastAPI, but yeah, you can actually like do that as well.
And not to go too far down the rabbit hole, but one of the challenges that I've seen with building these two separate layers of the API server and then the JavaScript application that interacts with it is the fact that on the front end, you end up having to do a lot of the same data validation that you would be doing in the back end if it was a fully integrated system. And I'm wondering what your thoughts are on that briefly.
Yeah, that's actually quite a common problem. And I think that's something that using open standards can help a lot. In FastAPI, when you build an application with FastAPI, if you want it or not, you end up building an application using an open standard, which is called OpenAPI. And OpenAPI uses the standard JSON schema for declaring the validation for the data types and like the shapes. It declares like validation and also like the shapes of the data and what are the types and what are the valid types of any interaction with data. You can actually, and that's also something that we have done, you can actually extract these JSON schema definitions for the entities, let's say for the post request that your API is going to expect. And then you can use that same JSON schema and integrate it with a front-end framework. There are, for example, plugins for React that allow you to generate a form based on that JSON schema and apply like the same validation that is going to be applied in the backend. So it's actually something that can get some benefit from the fact that it's using some open standards.
And there are a number of other different fashions of web APIs that have come about, and there are some different generations, OpenAPI being one of the more recent ones, and another being GraphQL, but there are also things such as JSON LD or the sort of quote-unquote traditional REST, and I'm wondering what's involved in adding support for some of those additional specifications beyond OpenAPI?
Yeah, so OpenAPI is more or less like a way to define a kind of bare bones REST API, more or less, like all based on JSON, but it doesn't like assume much. So you can build almost anything with OpenAPI. With something like a JSON LD, which is JSON linked data, that assumes a little bit about how is your data laying underneath, like what are the relationships that your data has. So to build something integrated with JSON LD, whatever tool you use, it will require the tool to know also how the data is stored and how the data is communicated and like handled in the database. So it will also depend on the database. So it requires the tools to be tightly coupled, and that's something that you not necessarily always have the chance to do. For example, if you are using a NoSQL data system like a MongoDB or Redis or Cassandra or I don't know, you don't necessarily have like a very straightforward way to define what are the relationships between entities. You might not have like multiple interconnected entities whatsoever, or you might have like different types of data that is cached and then not cached. And so adding these tools requires a bit more of integrating them into the actual like data storing layer. But of course, you can also do it. There's people like building these additional, for example, JSON LD is still like a web API, like a web API system, and can be built on top of OpenAPI. And there's people like building, I don't remember if it was JSON LD. There's also like others building another of these JSON-based APIs. I don't remember exactly the name. But yeah, you can absolutely do that on top of FastAPI, but you will have to build some parts that integrate with the tool, with the data storage directly. For GraphQL specifically, GraphQL is kind of its own standard. It has its own way to define data, its own way to define how to query the data, and it actually it doesn't use that much like HTTP standard parts. It uses POST for everything. And like there are some things that you can do, and there are some cases that it solves very well. For example, if you have deeply nested relationships and you want to query very specific data that has to traverse like these relationships, right? And you want to query some specific data in the nodes of these relationships, GraphQL is a very good tool to solve that problem. But for many other problems, it's like it's not necessarily the best approach to solve them. For example, you wouldn't necessarily use GraphQL for a machine learning API that only receives some type of data and returns a prediction, because that would require like even making the clients talk in GraphQL. So it's very good for some specific use cases, not necessarily for all of the use cases. But still, GraphQL ends up requiring specific libraries that are dedicated specifically to GraphQL. And the part that the API has to do is only provide a single post endpoint. So if you want to do GraphQL with FastAPI, you will probably use a tool like Ariadne and connect it with FastAPI, and then you can provide more stuff on top of FastAPI. But it's probably building stuff with GraphQL probably requires a bit more of GraphQL specific libraries.
And as we mentioned before, there are a number of other frameworks available just in the Python ecosystem for building various types of web applications. I'm wondering if you can just give a bit of your sense of where FastAPI fits into that broader ecosystem and some of the reasons that somebody might choose FastAPI over some of the available options.
Yeah, so like, for example, one of the ways people might want to use FastAPI is to complement some existing applications. Let's say you have a Django or a Flask application, and you want to add additional features on top that are just like purely API based, and you want to integrate that with the rest of your application. You can generate database models that use the same database that your other application is using, and you can add these extra features on top with FastAPI that will be probably a lot faster to write the code itself. It could improve performance. It will probably improve performance because FastAPI gives you performance that is like on par with Node.js and Go. It's a bit faster than some of the Go frameworks, and that's like pretty cool, given that Go is a compiled language. So like for some cases where you need to add performance, or when you need to add WebSocket support, or when you just need to like build some extra features that are API based, that will probably be a good use case. And nevertheless, there's a lot of people that are migrating their current applications to FastAPI just because it ends up easier to like manage the same code base, and it's for some of these users it ends up being easier to like manage FastAPI code. But yeah, like also like if you want to build new features, if you want to build a new project, if you want to reduce code duplication, and like the fact that it provides automatic documentation that can be used for by clients, by the front-end team, by other backend teams, that's also probably a like a selling point for FastAPI, because in this new startup world we live in, where like there's deadlines all the time, and there's not a big chance to like build very thorough documentation of every feature that you build. Having the tool generate the documentation for you, and the validation and the serialization, everything just by you writing your code normally, that's something that is probably quite appealing.
And you mentioned that the type annotations being a first-class concern of the framework helps with the developer ergonomics, and I know that in reading through the documentation, that was also a consideration in terms of how you built it to be optimized for developer workflow with the editors that most people are using. I'm wondering if you can give a bit more of a background of the design philosophy and your overall approach to building out this framework and the considerations that were incorporated into it.
Yeah, so actually like the design of how the API, let's say like the API to use the package, not like how you build an API, but like the design of how FastAPI itself works had like a lot of just design itself of how it should feel like, of how you should like work with it in the editor, even before writing the internals of the code. And then the internals of the code were written to match those expectations and those ideas that I wanted to have, because it's all made so that you can have auto completion everywhere for almost like everything, or like for everything. everywhere you can have auto-completion with FastAPI, you will have it, because most of us, like mortal developers that can't memorize everything, use a lot of this auto-completion. So it was made to work with that. Another key factor in the design was to reduce code duplication, so that you don't have to declare the same data in multiple places, but that you can declare like in one single place, and then that's the only place where you have to declare it. For example, if you declare that you're going to receive a body, and the body has to have some specific shape and has to be validated in some specific way, and is documented as having that shape, you only have to declare that type once, and then the rest is done automatically, so that you don't have to duplicate code in different places that then you have to make sure you keep in sync, and then you have to make sure that it's not obsolete, and whenever you refactor it, you just have to change it in one single place. So that was another of the key factors. And the other key factor was that the whole framework is built around standards. The whole framework is built around OpenAPI, JSON Schema, and OAuth 2. So like the way that you interact with it, the metadata that you declare, everything is made to match these standards, so that you can very easily build something that is already like, let's say, applying best practices and following standards just by writing your standard common code. So I think that those are like the main key factors in the API design.
And I know that you also built the Typer framework for building CLI applications with some of these same concerns in mind of improving developer ergonomics and being able to lean on type annotations for automating a lot of the ancillary aspects of building out these different programs. And I'm wondering what the relationship is between the two projects and how working on one influenced your thoughts and design decisions on the other.
Yeah, so while working with FastAPI and like using these type annotations and realizing that it was actually useful and it ended up being a good idea, and being able to use just functions and declare standard Python type annotations was a good idea, and that it improved like productivity and stuff. Then I also realized that there was no framework for doing the same for command line applications. There were several like inspirations and tools. For example, Hug, which is also an API framework, API and CLI. Hug was built before there were type annotations, so it wasn't able to use standard type annotations internally. So the way you create the code is not as simple as just like writing standard Python code with annotations. But still, like it had all these ideas, and there were several others that had these ideas of annotating the data, declaring additional metadata and validation and stuff in the same declaration of the functions parameters. And I just realized that there was no tool providing that way of interacting with it, and that way of like using it just with plain modern Python. So that's why I ended up building Typer, and like the design is almost exactly the same as FastAPI. So if you are using FastAPI, using Typer is like feels like doing the same. But actually, what powers Typer underneath is Click, and it's all just done by Click. Typer is just like a very lean layer on top to simplify development, so that you don't really have to learn much. You can use type annotations, you can just build a function and then just use Typer directly. In fact, I recently built also like Typer is the library for building CLIs, but I also built this new package called Typer CLI, which is a package to be used in the command line that lets you use any Python file that has a function and can convert it into a command line application by using that command line package. And then you get autocompletion for free for your scripts without having to create like a full command line application or like a full package. So like these tools and these ideas, like it's just like to simplify development and to simplify the way you use it, so that you can think the less possible in the library and just like the most standard Python possible to get like this functionality. That's the main idea, I think.
Digging deeper into that experience of the developer, can you talk through the workflow of getting started with FastAPI and some of the ways that workflow evolves as you start building out more complex and bigger applications with it?
Yeah, well, actually, writing applications with FastAPI ends up being like a lot of just writing the business logic, like the business logic of your own application. You actually don't end up writing a lot of FastAPI code itself. Because like it just tries to get out of the way. But you normally just like write your own code and like use the tools and the packages that you would normally use. For example, you don't have to have like plugins or integrations for doing most of the things, because you can just like write plain functions and then like, for example, use dependencies which are integrated in FastAPI. And for something to be used as a dependency, it just has to be a function that has parameters. So you can also like use standard libraries and standard packages that you are already using for many of these tools and features. So it's mostly just like writing your own code. It's just like you add some small layers on top of the code that you're already writing, and then you get an API. It's mostly that. I think that's mostly like the workflow that you end up having.
I know that with Flask, for instance, if you want to modularize the application, you end up using their blueprints interface for being able to build out these components that can potentially be plugged into other applications. I'm wondering what the analog would be in FastAPI and how that manifests.
So FastAPI has a similar thing, which will be an API router, so that you can have like a main API in some file, like a main API app in some file, and then create additional like routes, additional routes or additional path operations in some other files, and then you can import them in the main file and just integrate them together. It's actually pretty simple, and you can also like add specific requirements for different subsections of your application through that. But it's quite simple, and it's probably similar to Flask Blueprint. But yeah, it's mostly that.
Digging deeper into FastAPI itself, can you talk about how the framework is architected and some of the ways that its internal design has evolved since you first began working on it?
So FastAPI is actually Starlet. Starlet is the framework I was talking about, built by Tom Christie. Tom Christie is the same creator of Django REST framework that I think you interviewed like in February or something like that. FastAPI is actually just a Starlet on steroids. And the steroids are mostly Pydantic. So those are the main two key components. And what it does is just like glue them together. Pydantic is a library built by Samuel Golding for doing data serialization, validation, and documentation. And then FastAPI puts these two things together and adds some extra layers on top of some extra functionality. For example, handling dependencies, because FastAPI has a simple dependency injection system that allows you to like deduplicate a lot of the code and like modularize the way you add requirements to each one of the endpoints. But then, like most of the FastAPI code is dealing with these two libraries that are what is actually doing the hard work underneath. And the other key thing I think in FastAPI internals is that there's a lot of code duplication in FastAPI itself, like in the internal code, just to provide a little bit of extra functionality for end developers, for end users of FastAPI. So, for example, there's a lot of method declarations that include like all of the possible key arguments, keyword arguments for the methods and for the functions, and that could be used like just it could have been done like just as a KWRs parameter that receives just everything, but I wanted it to have autocompletion everywhere. So there's some extra effort into managing that and maintaining that, just so that we developers using FastAPI can like have those extra benefits of having autocompletion and type checks for everything everywhere. So those are like the main aspects internally of FastAPI, but the main work is actually done by Starlet and Pydantic.
Yeah, things like that of exploding the kwargs into the actual individual keyword arguments is one of the things that definitely benefits the end user. And I've definitely been in the situation of having to dig 3 or 5 levels deep into a different set of function stacks to say, okay, well, here's a kwargs that's getting passed into something else. What does that require? And then what does that require to actually finally get the list of accepted keyword arguments rather than being able to have that available at hand at the top level function. So the care that you put into the framework is definitely evident in things like that, as well as the extensive documentation that you've provided, including a lot of the history behind the framework and some of the reasoning behind how you came to these different design decisions. And so I'm wondering how you managed to find the time to have that level of care and detail and some of the challenges that come along with that level of dedication to the framework.
On one side, exactly what you were saying about the expanded QRs everywhere, like that's something that has been difficult for me always, and like having to dig very deeply into documentation of other libraries to find out what are the available parameters. Like I wanted people to be able to install and almost like never come back to documentation because they could just do everything with auto completion. So that was one of the like the objectives I had. So I guess that helps motivating. On the other side, I guess like unique privilege of working for a company that gives a lot of value to open source, and like they give me time to maintain my open source tools, like apart from work. So like I dedicate like some a fifth of the time I'm working purely to the open source tools I'm building. Also because like we use them internally, but it's not necessarily common for a company to like give people time to develop open source stuff. So that helps a lot. And on the other side, I think I have a very patient wife because I dedicate a lot of my free time just to these open source tools. So like all the afternoons, all the weekends, I end up like solving another issue and doing these things. But it's also like because I really like it. Building the tool, I like using it and I like enjoying how it works. So I want to build it to solve my use cases too. But I really like the feeling of helping others and knowing that it's being used by others and that it's helping others like build their tools and like help them solve their social problems, their community problems, like their products, and I really like the idea of helping others build stuff and like just doing a little bit of extra to help with that.
Going back to the design of the framework, you mentioned that it has built-in dependency injection capabilities, and because of the way that it's designed, it's possible to just import different Python libraries and start using it right away. But I'm wondering, what are some of the specific extension points that you have exposed for people to be able to build various plugins for FastAPI and build out more of the ecosystem around it?
Yeah, so on one side, dependencies are like one of the main points where you will add stuff. Because you can add, like, for example, a database session management, you can do it in dependencies, but you can also like add authentication and security and authorization stuff in dependencies. So there's a lot of stuff that you can do in dependencies that gets executed even before your root handler functions is executed. So that's probably one of the main points where you will extend it, and that you don't actually have to create a new package or like a plugin or something. You can just like import the tool that handles like database sessions and just add it in a function. And like a dependency, it's a fancy word that in the end is just like it's just a function. In FastAPI, it's just a function, and you just add it there in the as part of the parameters of your endpoint handlers. The other main point of extension, I would think, is the ASGI, the ASGI spec itself. ASGI is like this new standard. I know you know, but for those that don't, ASGI is the new standard comparable to WSGI, to WSGI, I never know how to pronounce it. And ASGI has all these definitions and all these ideas of how to interact between an HTTP server and the Python code. It defines all those interactions. And there's a lot of stuff that you can plug in that is automatically compatible with all of these ASGI frameworks. So you can find like any plugin for ASGI and it will be compatible with FastAPI. For example, you want to add tracking with some API monitoring system. There's an ASCII plugin for that. Or you want to add Sentry to your API. There's an ASCII plugin for that. There's just like a lot of these plugins that are built just for plain ASCII, and you can just add them directly. You can also build one of those, but I guess people is probably gonna just end up using a lot of the already existing ones. And then like a more hardcore level of extending FastAPIs, you can also declare your own root class overrides. So you can define the extensions to the internals of FastAPI itself and the way it handles like the functions that you declare for your API. This is probably quite more hardcore, and I wouldn't expect many people to need to do that, but you can do it. And for example, there's this package called FastAPI Utils by David Montag that for example, allows you to use class-based views. I think that's the common term, so that you can declare your API using classes instead of plain functions. And that's the way it works. It just like adds and modifies these internals in the ways that, in the points that you can extend them and that you can override them. So yeah, there's plenty of places where you can integrate and modify and extend the things in FastAPI. But in most of the cases, because FastAPI is quite like plain and doesn't have a lot of assumptions on your data or your tooling or your components, you can in many cases just like add your standard code and it just works. Like you don't have to like make sure it integrates with FastAPI in most of the cases.
And as you mentioned, because of the fact that you are building on top of the ASCII specification and the framework is entirely built around asynchronous capabilities, it brings in that whole aspect of the Python ecosystem that is still relatively new and not a lot of people are necessarily familiar with. I'm wondering what you have found to be some of the design challenges in exposing that async capability in a way that is accessible to users without causing it to be too confusing.
Yeah, so like the first thing is that like the ASCII community is like incredible. For example, Tom Christie that has done a lot of work with Starlet, with Ubicorn. There's also like a lot of people like Florimond that is doing a lot of extensions and ASCII middleware and stuff. Like it's also one of the co-maintainers of HTTPS. There's also like Hypercorn. There are like several ASCII servers just to start with that. And like the community is great and like it's actually quite healthy, I would say. So it's strange that the community is quite new, like ASCII and all this async stuff is quite new, but I would say that it's very healthy and like growing very well and like creating a lot of innovation in the area. One of the main things I think is like difficult for people is understanding and thinking about when to use async and when not. And there's all this idea that if you go async, everything has to be async. If you go async, everything has to be async and everything has to be async compatible and stuff like that. And then like they just end up not using it because they don't necessarily know how to use these functions and where to put the await and where to put the async and all the stuff. But it's not really like that. For example, in FastAPI, using the same idea from Starlet, and it's actually just like done by Starlet, lets you use standard functions, standard libraries, and it just does the right thing underneath and runs any code that is not async compatible in a thread pool. So you don't have to deal with any of that, and still you get like performance benefits from that. So I think one of the main challenges is that people are scared of these async tools, and then they just like end up not using anything at all just because it might be dangerous. But yeah, like you can actually use FastAPI without ever writing any async code. So yeah, like I think that's one challenge. The other thing is older libraries that rely very heavily on thread local variables, they end up being a problem, not with ASCII, just with async in general, because in async contexts, a single thread could execute more than one task, and one task could be executed in more than one thread. So like all these combinations and the assumptions for thread local variables don't hold anymore. And there's actually the alternative of context bars that is available in newer versions of Python, and there are like backports and everything. But still, like there are many older libraries that don't. Actually, I don't know if that many, but there are some older libraries are compatible with these new ideas. Yeah, like it's normally in some specific use cases and some specific libraries that rely heavily on these things. But in most of the cases, it's just like fine. Like you can just work very well with these new tools, especially when using these ideas and these functionalities of being able to just to declare standard functions and like having the framework do the right thing for you if you are not using an async compatible or an async first library.
What are some of the other sharp edges that users should be aware of when they're working with FastAPI?
I think that's mostly it. Like handling older libraries. I think is handling older libraries that depend specifically on thread locals. It's not that dependent threading. Like they can use the threading and stuff, but if they do these magic tricks of using threading local variables, that's one of the cases where it can be problematic. I think that's probably one of the main cases where people should be like aware of that something could go strange in there. Also, like this idea of just adding async to everything when the libraries that they are using inside of a function declared with async is actually not compatible with async. That could be like a problem and degrade performance. But then, in the cases where people don't know where to use async or not use async, in FastAPI they can just like use plain functions without async, and it will just do like the right thing underneath and won't degrade performance. And like whenever they get the chance to like understand like all these async parts and like what libraries are compatible with each other, then they can take the extra benefit and the extra performance of that. But I think that's probably the main sharp edge that people should be aware of and like deal with care.
What are some of the other interesting or unique or underutilized features of FastAPI that users might not be aware of that you think they should use more frequently?
I think one of the important things that I think people don't realize very often is that they can use, for example, for security and authentication and all these things, they can use combine dependencies in sub-dependencies. And many times people end up subclassing the FastAPI dependencies, and then they end up having to duplicate a lot of the code. I think that's something that has to be improved in the documentation because I guess it's not that obvious. But in many cases, you can do like very complex interactions between the dependencies. For example, you could require a user to have like a token authentication or a cookie, or to be like, I don't know, authenticated in some other way. Like it has to be one of those different things. And then you can combine all that with dependencies in a sub-dependency that then is added to an endpoint function handler. And then like the way you combine them is just like in a simple function that takes the values from the other dependencies. You don't have to create a subclass, something that does something like quite complex to get all the possible attributes and all the possible values from different places. I think that's one of the features that people don't necessarily realize. Another one is using OAuth to scopes. I think this is probably quite underutilized because it provides a lot of flexibility, but the same as OAuth 2, OAuth 2 is a complex specification, and it's like a complex subject, and it's a complex interaction because like all the combinations and all the ways that it can be handled. Like OAuth 2 is the system that is used by Facebook, Google, GitHub, Twitter, all these guys to provide like third-party authentication and the login with AppX and all that stuff. And FastAPI has a support for all these things like built in. But all the way these things interact with each other is actually complex at the abstract level. Not even talking about code, like the way everything interacts is not necessarily so obvious. So I think it's something that people don't realize that they can actually do with FastAPI. But it's also like one of the points that needs to have like even more documentation in FastAPI itself. I think those are the main two things that are probably underutilized of FastAPI.
And what are some of the most interesting or unexpected or innovative ways that you've seen FastAPI used by either yourself and your projects or other people who have been leveraging it?
So, for example, recently I saw this. Someone built the coronavirus tracker API with coronavirus API data, and it was like, oh, that's. I think that's very cool. That it can help someone build something that is useful for us, like as a society right now, and be able to like get like accurate information easily and like handle it and deal with it with code, which is the thing that we can like provide and the tool that we can use to help. So I think that that's a very cool use case. Another one is that Chad Smith, the creator of PipX, created this application called Term Pair that allows you to handle your terminal from the browser and like see the terminal session live in the browser, and it's all built with FastAPI and WebSockets. And I think that was like a very cool application that I hadn't thought about, like that you could actually do that, and it's like all built with FastAPI. That one was very cool too. Another one is XPublish, which is for publishing Xarray as an API, which is like a kind of distributed NumPy integrated with Dask, and then like they publish that as an API through FastAPI. I think that's a very cool use case. Also, like some of the applications built by Uber and Windows and Netflix, they are using FastAPI in some way. I will share the links with you later. I think it's very cool to see like these very known companies also using these tools and like seeing that it's useful for all the levels of organizations.
And when is FastAPI the wrong choice for a web framework?
So if you already have an application that is not necessarily based on an API, probably not based on an API, let's say you have a Django application and you don't need to add any new features, it's already working, you don't have to change it, like there's no need to migrate it to FastAPI because, like, you know, we as developers, we like to refactor stuff and change stuff. But if something is working and it doesn't need to be changed and like there's no need for extra performance, like there's no need to change it. Like I think that will be like one of the main use cases where you wouldn't want to use FastAPI. Like if you have something that is working and you don't have to change anything and like there's no need. Another case is if you are building an application that is not an API and that you want and you need to build the whole application with templates in the backend, and you really need an administrative interface for handling the data in a database, that's probably not a very good use case for FastAPI. The thing is that more and more these modern applications require being built as an independent API and front end. So I think there are more and more FastAPI ends up being the right choice. But if you are in one of these use cases where you need to build something that is based on backend templates, you are probably better off with the tool that you already know. Given that, you can still do that with FastAPI. You can use Jinja templates. You can use SQL Alchemy database models. And you can like replicate the same thing that you will do, for example, with Flask. But then you are not getting like any specific benefit necessarily. So if you already know how to do that in some other way, then you're probably better off like with that way that you already know. And another use case is for building like a static website, a static web application. I think like using something in the Jam stack, like JavaScript APIs and Markdown or Markup will be like a better way to handle it. For example, using Next.js or Hugo or Gatsby or one of these tools that generate a static web page or like a static web application that doesn't really require any interaction with a backend server, then like there are better tools for that. And it's actually not related to FastAPI itself, but related to building a backend application to serve something that is actually just like static content. I think there are modern ways to do that in a better way. I think those are probably the main cases where FastAPI is probably not the right choice.
And in your experience of building and maintaining and growing the FastAPI project and some of the surrounding ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think a key aspect I think I learned is that it was actually possible. Like I'm just like some random guy that had one idea and had one problem that I wanted to solve, and like I just like put my work on it, and I just like decided to do it and to try and to solve that problem, and it ended up being quite useful. So realizing that you don't really need a genius to build a tool that is useful for others, that solves your problem, solves other people's problems. You can be just like a very normal person like me, just willing to do the work to solve a problem. That's all it takes. That was a very cool realization. And another one was that community actually helps a lot. Like people are willing to help. I was hoping for people to help and to help others and to like join the community and like help other people, but I was hoping for it but not necessarily expecting it. And I have realized that there's a lot of people really helping others. Like when you go to the issue tracker in FastAPI, there's a really a very nice people and a bunch of people that are just going there and helping others with their questions. And like in the Gitter chat that now has like more than 700 people, it's just too much for me to help everyone that asks questions there. And there's a lot of people that are there just like helping others. And it's just like to help the community. So that's been something, an awesome realization as well. And like one of the unexpected challenges and learnings has been like, internals of Python. Just learning a lot of how Python types work. And so, for example, undocumented features and undocumented ways of how Python handles types internally, because they are used by Pydantic, which is the tool that powers FastAPI internally. So like handling, being able to see all these inner workings of these tools is also like mind bending sometimes, but it's a really good learning path, I think.
What do you have planned for the future of the framework and any new or improved capabilities?
So one of the main things is FastAPI has a lot of documentation, but I think there's still a lot of extra documentation to add. I already have like my own internal backlog of the ideas I want to add. For example, I want to add a lot more of out to the documentation. For example, how to use other authentication providers like GitHub, Facebook, Google, things like that, and how to build your own authentication provider and how to build your own system that allows, for example, third-party applications to interact with it in behalf of your users. Things like that. They are normally like kind of complex topics, but they are quite easy to build with FastAPI, but it's just not very well documented yet. So I think that's something that has to be documented. Another thing is that there are a couple of full stack project generators based on FastAPI that build like they help you like quick start your application with the full backend, simple front end, all Dockerized with some database and some asynchronous job handling. And I have to update some of the parts of it to like use the latest like features of FastAPI itself. And the other thing I really want to do is build a React admin user interface using like the new tools and ideas in React using TypeScript and using hooks that has been like a very development experience. So I think it's something that can work very well and can help a lot to like being able to have like a generic admin user interface that integrates with FastAPI. That's one of the main things I have like for the long term, let's say, future for FastAPI.
Are there any other aspects of the FastAPI project or your work in open source or asynchronous web frameworks in general that we didn't discuss that you'd like to cover before we close out the show?
It's funny that it seems like this is like quite new, like all these async ideas and async tools and stuff. And it sounds like it's very new and moving very fast. And it has like this, probably like this feeling of young and maybe immature or something like that. But then if you look closer at these applications and these tools, like most of these applications are really lean. They have like very little dependencies, and most of them have like 100% test coverage, and they have like a lot of like type annotations. Like most of them have like 100% type annotations. Like, it feels like if it was quote unquote immature, but it's actually like with very, very high standards of code quality. And I think it's it's just like that we want to be super safe in how we build these things and like to make sure that we do the right decisions and the right things in APIs. But even though many of these libraries have versions that are even pre-1, for example, FastAPI is version 0.50 something, but it already has like a lot of background compatibility layers and stuff to be able to be compatible with previous versions of the old libraries. But I think like the Async ecosystem is very healthy and actually very mature, even if it looks quite young still. And I think, it's a good time to start playing with it and start trying these tools and these ideas and using these new techniques and these new tools.
Well, for anybody who wants to follow along with the work that you're doing or get involved or get in touch, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose the show Once Upon a Time that I started watching recently. It's an interesting TV series that focuses on all the different fairy tale and fable characters and remixes a lot of the stories that we're familiar with in interesting new ways. So I've been enjoying watching that recently as a respite from reality. So I'll definitely recommend that for if you're looking for something to watch. And so with that, I'll pass it to you, Sebastian. Do you have any picks this week?
That's very fun. I know my wife really likes that show too. I haven't watched it yet, but I know she really digs it. And yeah, I have like a couple of picks. One is the Cloud Atlas movie. It's actually super long, and I think that's why many people has not watched it yet. But I watched it like, some months ago, and I really liked it. It's very long, but it's very interesting. Like all the philosophical concepts involved are very interesting. It's from the same guys of The Matrix, the Wachowski brothers. It's quite interesting. Another one is the Isaac Asimov's robot short stories. Like Isaac Asimov is the one from iRobot. Is the one the guy that coined the term robotics. And the story is just science fiction, pure simple science fiction, but it's like really interesting and really, really enjoyable. And on the tools side, I would recommend Python DevTools. There's this package by Samuel Colvin called DevTools that has a debug function that you can use in your code, and then it will print any variable that you pass to it, pre-printed, showing which line it was called in, showing what was the function that was calling it, like a lot of information that is super useful for debugging, where you cannot just like plug a debugger. And I think it's quite new and not many people know about it, but it's a real lifesaver. And another one is HTTPX, which is the new async compatible request tool for Python. So you can do like HTTP requests in async contexts and also in standard like normal function non-async contexts. I think that's it. Also, I actually have a couple of other apps that I wanted to share with you. Now that we are like all in our houses, Rescue Time is a very good app for tracking your time on the time that you spend working and like do it automatically. And the other one is Joplin for taking notes. I will share the links with you when we finish. That's it. It's actually quite a bunch. I probably should have picked less, but yeah, whatever.
No, it's helpful to have all those different suggestions, so I definitely appreciate that, and I appreciate you taking the time today to join me and share the work that you've done with FastAPI. It's definitely an interesting framework and one that I've been hearing a lot about from a number of different people, so you've definitely been doing something right, and I appreciate all of your time and effort on that, and I hope you enjoy the rest of your day.
Thank you very much. Thank you for having me here. It was a real pleasure. Have a great day over there too.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.